Hello there. In this video we're going to continue our discussion on the properties of some elementary operations, in this video in particular radicals. So in the previous expositions we talked about properties of exponents, in particular exponents that are of, say, fractional order. For example, we showed that x to the m divided by n is actually equivalent to that of the expression the nth root of x to the power of m, assuming that here n is a non-zero number. So we're going to take this property and build other properties associated with just radicals, and we're also going to remember that the square root of x squared is of course equal to the absolute value of x. So the square root of 4 is 2 and only 2. So we're going to be using these principles in order to build and do several examples of radicals. Alright, so the first property of radicals that we're really going to investigate is one that some people tend to misuse on common occasions, and that is the expression the square root of a times b. So, of course, the square root is the same as writing a times b to the power of 1/2. So since 1/2 is an exponent, we can sort of distribute it over this product. And rewrite this as a to the 1/2 times b to the 1/2. So this is of course equal to the square root of a times the square root of b, provided that all of these expressions are defined, which is guaranteed if a and b are both greater than or equal to 0. Alright, so let us look at an example where some people tend to try and bend the rules a little bit. So example, consider the square root of 16. So we can of course rewrite the square root of 16 as the square root of 4 times 4, and then rewrite this as the square root of 4 times the square root of 4, which is 2 times 2, which is equal to 4, right? So this is of course true, no problem there. So what happens when we decompose 16 instead as -4 times -4? So this expression here that we've written, we actually have done nothing wrong here. Now if we assume that this property is well justified, if we split it up into the square root of -4 times the square root of -4, this is not true, right? Because x and y are both non-positive numbers. Now if we split this radical, because remember that this expression lies within the set of real numbers. Once we make this transition, we are no longer in the set of real numbers, right? Because this number is in the set of complex, this number is in the set of complex totally, right? So we have changed the world that we are in, right? Because we're not obeying the rule that we stated before. So if we continue with this argument, you're going to get this is going to be equal to 2i times 2i, which is 4i squared, which is equal to -4. And this is sometimes where people say, oh, the square root of 16 is 4 and -4. No. Remember that this represents the principal branch of the inverse of the square relation, right? And this represents the secondary branch, which by this logic requires us to go into the complex plane to sort of come around to it, right? So remember, this is not valid, right? Because we are changing the branches in the middle of our calculations, which you can't do, right? So just keep these little things in mind. So if we have something like the square root of 20, we can decompose this into the square root of 4 times 5, which, since both are positive, we can rewrite this as square root of 4 times the square root of 5, which is 2 times the square root of 5, right? 5 is a prime number, so we tend to call this our simplified radical expression. And if I have something like the cube root of 54, I can rewrite this as the cube root of 27 times the cube root of 2, which of course is equal to 3 times the cube root of 2, right? So that's our simplified radical expression. Now, in some classes, you may hear the term rationalize denominators. Now, depending on the field you are, this may or may not be too important, but if they ask you to do this, then you should be able to do so. And what they mean is, so suppose we have something like 4 divided by the square root of 2. So when they say rationalize, you want something of this form, but without radicals in the denominator, right? So you should only have real numbers that are not square roots, cube roots, and so on that don't simplify. So one way we can take care of this is we can rewrite this again as 4 over 2 to the power of 1/2. And I'm going to take the scenic route temporarily, right? So I want to get rid of this 2, so I have half of a 2, so I need to introduce another half in order to get a whole, right? So I'm going to multiply top and bottom by a half of 2 in terms of powers. So once I do that, so I have a half a 2, so I'm going to have a whole 2 there. And then I'm going to have 4 times the square root of 2 on the top. Clearly this does simplify, so this is just equal to 2 times the square root of 2 as our simplified answer. So if I continue this process for something with cube roots, so suppose I have something like 20 divided by the cube root of a 5. So I can rewrite this as 20 over 5 to the 1/3. So I have a third of 5 there, so I need to introduce 2/3 of a 5th here in order for this to sort of give me a whole 5. So this is just going to be equal to what? So we'll have 5 on the bottom. I'm going to have 20 times the cube root of 5 squared there. So 20 divided by 5 is going to be 4. So I have 4 cube roots of 25 as my final answer, right? So that's my rationalized expression. So let's look at an interesting looking expression, namely the square root of 2 to the power of the square root of 2. So let's sort of investigate this temporarily. So we can rewrite the square root of 2 as 2 to the power of 1/2. And I'm going to keep the other square root of 2 there. So remember, when I have a power to a power, I'm going to multiply these things together. So this is actually just equal to 2 to the power square root of 2 over 2. So what I can do is I can multiply top and bottom of this expression, so times square root of 2 over square root of 2, and then I'm just going to have 2 on top, right? So I'm going to have square root of 2 times square root of 2 is going to be 2, all over 2 square roots of 2. So that's of course equal to 2 times 1 over the square root of 2. So this is just equal to the square root of 2th root of 2, right? So these two expressions are the same. Very interesting looking expressions, but under certain circumstances you may want one expression over the other. Let's assume you have 1 over 3 minus the square root of 5. So when you have things like this, what you can do is you can multiply top and bottom by the conjugate, 3 plus the square root of 5, and then you can use your difference of squares relationship, right? Because this is a minus b, this is a plus b, so this is going to go to a squared minus b squared, and the square will delete the square root symbol. So this is going to be 3 plus the square root of 5 all over 3 squared minus square root of 5 squared. So that's going to be equal to 3 plus the square root of 5 all over 9 minus 5, which is 4. And if we want to continue, we can decompose this fraction if we want. And we can rewrite this as 3/4 plus 1/4 square root of 5. Depending on how you want to present your answer, maybe you want this versus that. Alright, let's just look at a couple more examples on how to deal with radicals, just in case you're not familiar. So let's assume we have the square root of 8 divided by 2 square roots of 7. So I'm going to get rid of this radical on bottom, so I'm going to introduce the square root of 7 top and bottom. So I'm going to have the square root of 8 times 7 all over 2 times 7. The square root of 8 can be decomposed as the square root of 4 times 2. And we know that the square root of 4 is 2. So we have 2 square roots of 2 times 7 all over 2 times 7. We clearly see it 2 cancels, and nothing else can be reduced. So we can rewrite this just as the square root of 14 all over 7. And let's assume we have a more intricate example, something with variables. So the square root of 8x multiplied by the square root of 10x minus the square root of 5x. And let's assume that x is a positive number, or non-negative. So I'm going to begin by distributing. So that's going to give me square root of 80x squared minus the square root of 45x squared. 40. So notice I can break down 80 into 40 times 2. So this is going to be the square root of 40x squared times 2 minus the square root of 40x squared, right? So this is just going to be equal to what? So the square root of 40 is just the square root of 4 times 10. Right? But what is the square root of 10? Well, 10 is actually the same as 2 times 5. Right? So I have a 2 that is coming from here, and I'm breaking down 40 as 8 times 5. Right? So I have these 2 here. So 2 times 2 is 4, and then 4 times 4 is going to be 16. So this is actually going to be 16x squared here. Right? If I want to write it like that. And I can do it the same here, right? So I can rewrite this as 4 times 10x squared, right? So this is the square root of 4 times 10x squared. Oh, and let's not forget our lonely little 5 that we had there. Let's not forget him. Alright, so what do we have here? So square root of 16 is going to be 4. Then we have 5x squared minus 2 square roots of 10x squared. So remember, the square root of x squared is going to be equal to the absolute value of x, and I have that in both of these terms. So I have 4 absolute value of x, square root of 5, minus 2 absolute value of x, square root of 10. So I can factor out an absolute value of x and also 2 if I want to. So 2 absolute value of x multiplied by 2 square roots of 5 minus the square root of 10. If I really want to be extra about this, I can break down 10 into 5 times 2. But that would be okay, I guess. So then I have 2 square roots of 5 minus the square root of 5 times the square root of 2. And I can pull out a square root of 5 if I want to, right? So then I have 2 square roots of 5 times the absolute value of x times 2 minus the square root of 2. And that would be another representation for the expression that we started with. Anyway, I hope these examples gave you some idea of what you can do with exponents, radicals, whether it be constant or variable terms. Hope you enjoyed.